Hello, my name is Eitan Suez, a technical marketing manager at solo.io. In this video, I'd like to discuss Ambient Mesh with Istio, of course, and API gateway integration. And so to explain more or less what this video is about, when we think of a service mesh, and specifically Istio Ambient Mesh, we control the traffic, the communications between microservices and workloads, and we have proxies in the path of those communications, those connections between these workloads in the form of layer 4 proxies, the Ztunnel component, and optionally waypoints. Now, with Istio, we also are able to provision ingress and egress gateways to control north-south traffic as well. But typically, we are more likely to encounter situations when an organization uses its own API gateway product at ingress. And so that begs the question, well, how do we integrate our API gateway with our mesh workloads? Right, now this is something documented on the ambientmesh.io website, and I'd like to just quickly glance at the page, which is titled Integrating Third-Party Gateway and Ingress Controllers. All right, so let's try to get an understanding of the scenario. Right, here's an illustration showing a specific type of gateway at ingress, which is essentially the entry point into requests from external clients to specific API endpoints or apps or what have you running on a Kubernetes cluster. Now, if this cluster were to run an Istio Ambient Mesh, then we see here the communication between those services, those workloads, are using mutual TLS. That means it's encrypted, it's secure, there's workload identity, there are policies that can be applied. And what we essentially wish to do is route requests that are incoming from external clients to applications running in the mesh. And there's nothing per se that is preventing us from doing that, right? I mean, we can configure and program our API gateway to route requests to backend workloads that are mesh workloads. There's nothing wrong with that. So I'd like to begin by discussing how communications in a mesh actually function. Right. We have the Ztunnel layer 4 proxy. It's a daemon set. There's one running on every node in the cluster that acts as a proxy for communication, and it handles a variety of responsibilities, including the maintenance of and rotation of X509 based certificates for each of the workloads running on each node, and using those to establish a mutual TLS handshake when we have connections with other workloads. There is a tunneling protocol specific to Istio Ambient known as HBone, the HTTP-based overlay network environment that's utilized for this purpose. And so we know that we have communications secured inside the mesh. When we look closely at the sort of end-to-end path, right, from an external client to a workload running in the mesh, there's this conspicuous connection from, we could say the upstream connection from the gateway to whatever backend it's routing requests to, that is left unencrypted or unsecure. And that's really the thing that we want to be able to correct. And so when a gateway receives an incoming request, it's probably a TLS request that's terminated at the gateway, but the routing of the request to that workload is not secure. And so the first thing I want to do to explain how we're going to correct this situation is by taking a moment to understand how Ztunnel performs traffic redirection, because the idea is to add the gateway itself to the mesh. And so when we add any workload to the mesh, what really happens behind the scenes is a collaboration between these two components of Ambient, the Istio CNI agent, which writes the IP table rules in the network namespace of the workload, and notifies the Ztunnel pod to configure and create listening sockets inside that workload that are going to receive the actual inbound and outbound communications and connections. As if a sidecar were present inside that pod, except that none is. But anyway, it establishes this sort of secure connection through the Ztunnel, which is then able to perform the mutual TLS on behalf of the workload. So this is known as inbound and outbound capture. And the reason it's important to understand is because at that point, that workload, any requests that are coming in or going out are going to be captured by Ztunnel. So now we can sort of take this information and try to apply it to the context in which we're interested here, which is the gateway. The ingress gateway technically requires outbound capture and not inbound capture. And what I mean by that is when the gateway itself has to route a request to a backend service, that actually needs to be captured, and the Ztunnel proxies need to be involved, just like any mesh workload. But on the front end, right, the gateway receiving external requests from clients, that does not require a Ztunnel proxy. And so inbound capture is really not necessary. It's superfluous. And so we want to establish only capture in one direction, outbound capture. And we do this by, we can instruct Istio to bypass inbound capture through the application of an annotation. The ambient istio.io/bypass inbound capture can be set to true in an annotation associated with the workloads that represent the ingress gateway. And by doing that, we sort of realize this particular image or configuration. And so we can actually test this, and this is actually worthwhile doing. If we have given a Kubernetes cluster, we can install Istio in ambient mode, deploy some workloads, make those workloads part of the mesh, and we can then provision an ingress gateway and configure the gateway to route requests to the backend workload. And when we do that, we sort of are at a point where requests actually function, but that upstream connection from the gateway to the backend workload is not secured. And so in order to secure it, we make the ingress gateway a part of the mesh, and that's typically done by labeling either the pods or the namespace is more typical with the data plane mode equals ambient label, and then also disable inbound capture to make sure that we have the Ztunnel only in the path of requests outbound from the gateway and not inbound to the gateway. And so we can try this out, right? This integration achieves a secure end-to-end connection from client all the way to through the API gateway to the backend workloads. And we have a lab that demonstrates this, which we'll jump into in just a moment. Okay, so here I am in a sort of sandbox lab environment where we can demonstrate what we just discussed. We can begin by deploying a workload. In this case, I'm going to use the sample application HTTP bin and deploy it to the HTTP bin namespace. The next step is to install Istio in ambient mode on the Kubernetes cluster that's running inside this sandbox. I'll go ahead and kick that off. And we're going to avail ourselves of looking at and studying the Ztunnel logs in order to find out essentially what's going on, whether traffic is being redirected through Ztunnel or whether we have mutual TLS. And so I'm going to set up a two-pane view, and in the top pane I'm going to tail the logs of the Ztunnel components that are running. Okay, great. Now, the moment we make HTTP bin workload part of the mesh by labeling its namespace with data plane mode equals ambient, we should see something in the log it's indicating that this inbound and outbound capture has just taken place. The Ztunnel is set up the sockets we were discussing for both inbound and outbound directions in order to sort of intercept the traffic and establish mutual TLS. And so now HTTP bin is not being called by any other mesh workload right now. It's going to be called by a gateway. So we use the Kubernetes Gateway API to apply a gateway, and that will provision a gateway for us in the default namespace, which is not part of the mesh. Now we're going to configure that gateway with a route that will simply route those requests, incoming requests, to a particular host name to the HTTP bin workload. And when we apply that, we can then send a test request and verify that an external request through the gateway IP address is going to be routed to HTTP bin. And here we see a response that came from the HTTP bin workload. Now the interesting thing is that at this point, if we look at the Ztunnel logs, we will not see anything in that log line. We see the source and destination addresses and workloads. There is no SPIFFE identity associated with that request, and that is an indication that there is no mutual TLS taking place. Another way to verify this is to run the command istio ztunnel config workload, and looking at the protocol column, and notice that even though HTTP bin is part of the mesh, the gateway is not, and so we cannot have mutual TLS between them. And so to enable mutual TLS, we can make the gateway a part of the mesh. Since the gateway runs in the default namespace, we can label the default namespace with data plane mode equals ambient. And now we rerun this Ztunnel config command, and notice that both workloads are part using the HBone protocol and part of the mesh. And so now if we sort of repeat our little curl request, we will see that this time we should see some SPIFFE IDs in the logs. Here we are. Source identity equals SPIFFE and destination identity equals SPIFFE. So the identities of both the source and destination are utilized to establish that mutual TLS handshake. But what's happening right now is that the capture is both on the inbound and outbound side. And what we really want is the Ztunnel to be in the path of outgoing requests from the gateway, but it shouldn't intercept incoming requests from external clients. We can perhaps see that better when if I run another curl request, we can see that direction inbound, the first line that showed up here, is an interception of that inbound request to the gateway. Notice the destination workload is the gateway, and so that's something we want to resolve, and we do this by using that annotation. I can patch the deployment for my gateway here with the annotation bypass inbound capture equals true. And so by doing that, and we can verify through some kind of kubectl command that we have an annotation now set on the pod, and so the subsequent requests will not have inbound capture, strictly outbound capture, and we can submit another request to our HTTP bin workload through the gateway, and note that the absence of that there was a third log line for the inbound request to the destination workload of the gateway that is now absent. It's not there anymore. Okay, so that is a demonstration of the concept we just discussed. Hopefully that makes sense. So the takeaway is that we can achieve end-to-end secure communication in a request to backend workloads through a gateway using an API gateway with a backend service mesh workload. All right, thank you, and we'll see you in another video.